Okay, so for plotting purpose we will use Matplotlib, and I guess we are not using this, so let me remove it. From Matplotlib import pyplot as plt. Okay, let me run this. Okay, I think I need to install source. Okay, I guess we are good. Let me rerun it. Meanwhile, let's go down and create the plots. So we have now all these things, so we will use subplot to plot because we have how many, 1 2 3 4, so I guess 4 comma 1 and so on, which is basically, yeah, this is what we want. Let's see if it is done. Okay, so I hope you're familiar with Matplotlib. In case you're not, we are going to plot all these into the one curve. So we will have 4 rows and 1 column, per row, and that's what we are going to do here. So first we will do is plt.figure, create a figure with fig size equal to 16 comma 6, no, I guess 6 comma 16, because height cross width. So this is it's not random, it's based on experience. So for a 4 cross 1 plot, this should be a good figure. Okay, now moving ahead, we will do plt dot subplot 4 1 and the first element. Okay, so we'll create plt dot plot. First would be random result. Okay, label equals to random exploration. Okay, comma color equal to, let's say, red. Okay, so these would be one aspect. Then plt dot x label would be what, x-axis, right? So the first item would be our arm id, I believe, arm id. Plt dot y label, actually no, that would be iterations, no, iterations, and this would be rewards. Okay, so x label, y label, plt dot title, random exploration. What else do we need? And actually this is more of a CTR, so let's put it CTR, because end of the day rewards is nothing but how our CTR is improving over time. Okay, and plt dot legend. Okay, let's first see if this looks fine, and then we will plt dot tight layout, plt dot show. Let's see if this works, then we will move on and try other things. Okay, so how do we have random exploration, random? Okay, because we have 2 items, no? So what we can do is random result. So we will have x of 1 for x in random result. Okay, I guess this should work. And yeah, let's first see, and then we can improvise on the others. Okay, I need to rerun this. Okay, so this is how it's been going. Yeah, I think this makes more sense. Now this is our first plot. Now let's again copy paste this whole content. Similarly, we will have 2 3 4. So we will have greedy result CTR, which will be greedy result. Then we will have epsilon greedy result CTR, which will be epsilon greedy result. Then we will have UCB result CTR, which will be UCB result. Okay, so let's run this one, and we will copy paste it. 4 comma 1 comma 2. We will pick greedy result CTR, greedy exploration, color equal to blue, iteration CTR, greedy exploration CTR. Okay, then we'll again copy paste this 4 comma 3, 4 comma 4. Okay, epsilon greedy, let's make the color as green, purple.
It's 9:15.
Upper confidence bound, greedy result, epsilon greedy result, and then what is else, UCB result. Okay, iterations, upper confidence bound exploration CTR, epsilon greedy. Okay, greedy epsilon. Yeah, I think this should work, so let's run this one. Okay, I guess this should be 16.6 only. I guess I made some mistake here. Yeah, okay. So yeah, you can see how over the 1000 iterations, how have we received, the rewards and estimates. And yeah, that's about this. And one more thing that we can do is to make so basically this is your simulation till the 1000 iterations. However, we can do one more thing, that is actually, let me move it out of here because it's a separate computation. Run this and meanwhile create a new block. Where did it got created? Yeah, here it is. Put it here, and then what we can do is yeah, let's create compute cumulative rewards. Okay, so we will take in rewards. Okay, and then here we will do cumulative underscore rewards equal to I think we need one more library, sum. Okay, cumulative rewards equal to sum of rewards, and then iterations equal to I think for the labels we can do actually from np only. Let's have one more function, arrange. Is it not arrange? Is it 1 or okay? Yeah, my bad. Okay, so what we can do here is a range of 1 comma len of rewards plus 1 comma step size of 1. Okay, so this would be the arranged version, and then the result would be result equal to cumulative rewards, or maybe let's call it CTR. CTR is equal to cumulative rewards by iterations. Okay, and return CTRs. Okay, so I guess this works. Yeah, so let's just copy paste cumulative random CTRs equal to compute cumulative rewards of random CTRs, and let's just do autocomplete. Okay, let's run this one, and now let's see the cumulative one, which will give us a even better picture. Greedy, Epsilon-Greedy, and UCB CTRs. Okay, so you can see that how this overall improvement goes for different algorithms. And I hope, yeah, I mean, this is the main purpose, to demonstrate like how the random exploration comes to a conclusion. Epsilon-Greedy, and then greedy and Epsilon-Greedy. Actually, the exploration factor is too high. 0.1 is basically 10% of the time. Generally, you could consider 0.01 and this is upper confidence bound. So yeah, that's pretty much about all these concepts. I hope you got a good understanding of how the multi-armed bandit problem works and how are the different strategies that a reinforcement learning agent can use to, learn over time. That's all for this video. I hope you liked it. In case if you have any questions or comments, feel free to put it in the comments.